So this session is on the built-in classes provided by Genero, so that's the bulk of this chapter. At the very end, we'll also talk a little bit about what we call utility functions, and there's some extensions. So there's just a little bit more to do to be able to use these utility functions and extensions, a little bit more to do than the built-in classes. So we have them in a little bit separate section there towards the end. The agenda, I'm expecting to be about an hour and a half today. It could go a little bit longer. We always give ourselves 2 hours for a session, but I don't think this one will take the full 2 hours. Again, we'll take a break if we need it. The last session we didn't actually even need the break. We just kept plugging along and were able to finish, I think, in about an hour and a half. So we'll see what happens today. If I get long-winded, we'll take a break. And if I don't get too long-winded, maybe we can just finish it in about an hour, hour and a half or so. I always mention that during the training session, if you need to leave for any reason, work is calling, maybe home is calling, you're free to leave and rejoin anytime. That won't bother me or anybody else in the session. And if you miss a lot of it or the rest of it, you can always watch the recorded session. We do post the link out on our instructor-led training site. The same place that you went to register for the session. You look when the session's over, and usually by the afternoon of the session or tomorrow morning at the latest, instead of the Register Now link, I'll replace that with a Watch Recording link. So you can watch the session from there just like you can sign up for a session. And in the follow-up email, I always try to put a link for the recorded session there as well. So if you do want to watch the recorded session, watch for that email. And there's kind of 2 ways that you can find it that way, by clicking on the link in the email or going out to our instructor-led site. You can also ask questions during the session. I know I'm pretty bad sometimes not to notice questions. So if I don't see your question, or if for some reason I don't get to it, I get a little bit behind, I'll usually follow up because I will see those before I exit out of the training session at the end of the session. And I will get back to you by email if I don't get back to you in the actual session itself. Also, you can send me an email. There's my email address, lchildress@4js.com. So if it's something that might be a little bit lengthier or take too long for me to answer during the session, feel free to use that if you want to, and I'll get back with you. I try to go over the interface before we start the session so that you can find things like the chat interface or the raise hand option. I'll just spend a minute or 2 on it today because almost everyone has been in previous sessions, so you've seen this little introductory slide or 2 before. So here's your screen that you should be looking at, something very similar to what I have on the slide. This is our viewing area here on the left-hand side. Oops, I keep forgetting how sensitive this is. Hang on a second. There we go. This is the viewing area here on the left-hand side. And then on the right-hand side of the slide, you can see our control panel, they call it. So there's a better slide to go through the control panel. So here it is all blown up and bigger. So over here on the left-hand side of the slide now, you see your control panel. And you can see where to join the audio. You can use a phone or mic and speakers, which is what I'm using today. It's using the mic. If you click on the telephone option, though, if your microphone's not working well for some reason, or your speakers, even worse, aren't working well, you can click on that telephone option instead, and you should see a number that you can use to connect to the session that way. Whoops. Animation doesn't seem to be working so well today, so we'll do it without the animation. Right below that is the mute button. The mute button you really won't have very much control over because I have everyone muted for this session, but I can unmute you if you have any questions or you want to make a comment. You can send me a note in the chat interface that you can see down here at the bottom of the screen. If you send me a note, I should see a little bubble show up, and that usually tells me I have a chat message I need to look at. So send me a note if you want to be able to speak, and I will unmute you. The red arrow at the top, I missed that a minute ago, just minimizes your control panel. So you can use that red arrow to minimize and then expand the control panel again if you want it expanded. Okay, that's probably all the important parts. There is the raised hand icon that I talked about first. It's got the circle around it here on the slide. So if you click on that raised hand, again, I should notice you out there and respond to your question or your comment. Okay, so I mentioned already the session today is mostly about built-in classes that comes with Genero BDL. So by the end of this session, you should be able to define and use the packages that contain our Genero built-in classes. And here's a list of them on the screen. Grab a marker here. We have 3 classes that are built into the runtime system that don't require any extra work on your part to use or to manage with the built-in methods. And we have 2 packages over here, the OS and util built-in packages that do require just a little bit of extra coding on your part to use the methods. Very little though, very straightforward. They're not really a part of the runtime system like the other 3 packages, so you do have to import them, load them to be able to use them. They're very simple. Down at the bottom, these are the utility functions and extensions that we're going to talk about at the end of the session today. There's some utility functions that you can use, again, that just require very minor extra programming to use. The Java interface allows you to use Java classes in your applications, and the C extensions extension, that's kind of redundant, isn't it, allows you to use your own C extensions in your BDL code. So we'll talk a bit about those too at the end of the session. So the first real page of our PowerPoint presentation is just an introduction to classes, objects, and methods. Just out of curiosity, how many of you folks on the session today have worked with classes and objects, have done any object-oriented type programming? Give me a hands up if you've had any experience with classes before. Anyone? Okay, it looks like I'm going to say about half of you have already had some experience, it looks like, if I were to kind of tally it up. So some of you have experience working with them and some of you don't. So just as an introduction to using classes, if you've not worked with them before, a good analogy or metaphor for classes is to think of a class as a blueprint for a house, for example. So I can create a lot of houses from a blueprint, and I can create a lot of objects from a class or a blueprint. So in this case, our classes are blueprints. The objects might be the houses that we create from those blueprints. And think of methods as the things you can do to a house that you create with your blueprint. So functionality of the class or object. For example, if I've created a house from a blueprint, a method might be to change the paint trim color to red, for example. So a method is something I can do to an object that I've created with a class. So I didn't do a real good job with that metaphor. One of the first ones that I learned was the cookie cutter analogy or metaphor. You think of the cookie cutter as the class, and from that cookie cutter you can create lots and lots of cookies, which would be your objects. And then methods might be, for example, to have a certain color frosting for the cookie, or maybe certain colors for eyes for the cookie, that type of thing. So cookie cutters, blueprints are all analogies that you hear for classes, objects, and methods. One thing I would suggest for methods is to think of them kind of like global functions. So a method is very similar to a global function that you can use to manipulate your objects. There's methods to create new objects. There's also methods that you use to manipulate those objects after you create them. So very similar to functions if you want to think of them that way. So Genero, we said, comes with built-in classes. And all that really means is a built-in class is a predefined class, an object type that's implemented in the runtime system itself. So you don't have to write your own classes. You can just use the ones that are already predefined and utilize the methods that come with those classes. So a whole lot of functionality is the idea without you having to do a whole lot of coding. That's the idea with these built-in classes. Now the extensions and the libraries that we're going to talk about at the end of the session are a little bit different from these built-in classes. They're not part of the runtime system, and you do have to do a little extra work before you can use them. You do have to load them before you can use them. So classes belong to packages. Grab my marker here. So we're right here. And the syntax is here on the slide. We'll see this syntax all through the session. Package.className, where package is what they call the name of the module the class comes from. I think of that more like a group of classes. And then class name, of course, is the name of the class. And then a class has a whole set of methods that you can use to manage a specific domain. For example, at the top they use the Windows class as an example of a built-in class. So the Windows class or window class has methods that you can use to manipulate Windows. The example they give down here at the bottom is the DOM node class has methods to manipulate DOM nodes. Probably one of the most important things about working with classes and methods is distinguishing between what they call class methods and object methods. So we're first going to look at class methods on this slide. So a class method can be used more or less what I call right out of the box. You don't have to do anything special to use a class method with an object. In fact, it's common to use class methods to create new objects or get a reference to an object that already exists so that you can use other methods called object methods to manipulate that object. So here's an example of a class method called getArgumentCount. Notice they've used the proper syntax we saw in the previous slide. Here's our package name, dot class name, and then the method name there at the end. So this is a class method, meaning that we don't have to do anything special to use it. We don't have to define a special variable of the class type. We don't have to use a special method to get a reference to a particular object to be able to use the class method. We just use it right off the bat, right? No special programming required. So this example of a class method is just showing you the getArgumentCount method, which is very much like a function that's used to go out and get a count of the arguments for the current application. So that's an example of a class method. So with class methods you can see there's only one object to manipulate. You don't have to find a reference to the specific object that you want to work with. There's only one, and in this case there's one current program that we're getting a count of arguments for. Now object methods are different. Object methods do require a little extra work before you can actually use the method. You have to define a variable of the class type. Grab my pen here. All right, so you have to define a variable of the class type, and then you have to create the object or reference an existing object with a class method before you can use an object method on that object. So here's an example using the window class. Here we're defining W as a window class type variable. We're opening a window here in the code. And then right down here, you see an example of using a class method. This UI.window.getCurrent method is a class method, and you can probably tell from the name, the method's purpose is to get a reference to the current window. So this returns, if we look at the documentation, this would tell us that it returns a Windows object. And we've defined this variable W with the Windows class type that we're passing this reference back to. So now we have W, and W is a Windows object or a window object that has a reference to the current window. So we used a class method to get the reference to the current window, and now we can use an object method. The one they've selected for the example is called setText, so we can just use the variable with this method now that we have a reference to a current object. W.setText, and all this method does is create a title for our current window. So call W.setText, make the title New Order Entry. So that's probably the most important thing about using classes, any class for that matter, not just Genero classes, is distinguishing between the different types of methods that are available so that you can use them appropriately. So we have class methods and object methods. Class methods are easier to use. You don't have to define variables with the class type like we see in this example. We don't have to do anything special with a method to get a reference to an object or create a new object. In fact, we use the class methods usually to do that. Okay, so the first package we're really going to look at here, besides that example we saw, is the base package. Now, the base package is used to work with what they call base classes of the runtime system. But the base classes are actually application internals, like the example we saw a minute ago to get the argument count. That's an example of a class, the application class, for example, in the base package. So the application class gives you an interface to the program, like that getArgumentCount method that we saw a minute or two ago. The channel class is a very powerful class that you can use to read or write from files or to files, use pipes to execute processes, execute a process, read from the standard out, and make that the input for another process. So a very powerful class, the channel class. We'll see an example of that here in a minute or so. It's also, the base package is used to manipulate strings. So there's two classes for that. There's the string buffer class and the string tokenizer class. String buffer is used as a string handler. There's methods, for example, to uppercase, lowercase, the characters in a string. String tokenizer is used more for string manipulation. For example, finding what they call tokens in a string tokenizer objects, which is just delimited characters, anything between delimiters. Okay, I just have a little pop-up that says that the audio is not so good. So everyone do me a favor, let me put down your hands. Yeah, Aaron says the audio is cutting out. Okay, thanks, Aaron. One second, let me see if there's anything I can close. Sometimes that makes an impact. Let me get rid of that. Not a whole lot I have actually up and running. Okay. Is that any better? Did that make any difference? I really didn't do a whole lot. Okay. Everybody says it's okay. Well, that's very strange, isn't it? Okay, well, let's keep going and let me know if there's any more problems with it. Not sure what else I can close out, but I'll try. Okay, so we're looking at this base package. String buffer, string tokenizer are classes to manipulate strings. Down here at the bottom, we have an interesting class that only has one method called typeinfo, used for variable serialization. The idea there is to serialize program variables in XML format. So this typeinfo method is called a create method, and all it really does is create a node in the DOM tree. And of course then you could use another method from a different package that we'll talk about to actually write that out to a file. So essentially serializing variables, the contents of the variables in an XML format. So that one's a little different from the rest. It's kind of interesting. So here we're focusing in a bit on one of the base packages classes called the application class. This is the one we saw earlier where we were using a method from this class to get a count of arguments. So we see that again in an example. Here they're a little bit more extensive on the example. They've got a for loop here. So for I, which is just defined as an integer, equal 1 to base.application.getArgumentCount, display getArgumentCount I. So they're just using a for loop there to go through all the arguments and display the arguments. So that one's a very simple example of a class method. Right? We don't have to have a variable defined with the class type to use this. We just use it and display what we get back from the method. So there's another example of a class method. Here's an example from the base.channel class that I mentioned is very powerful. I remember in my 4GL days, to read from a file, we used a C program to do that. Nowadays, if we needed to read or write to a file, we can just use these built-in classes and methods, and the channel class is perfect for that. So we can use the channel class to read or write to files. We mentioned earlier the pipe option. There's an open pipe method you can use where you can read from the standard output of a process and use that to write to the standard input of another process. It has all kinds of methods where you can do things like check for the existence of a file, all kinds of good things like that. So let's take a look at this one, the example. Here they are defining a variable with the class type, base.channel. So here we're using a class method, let my channel equal base.channel.create. That's our class method to create a new channel. And then we're using an object method, open file, to go ahead and open a file, and we pass it a variable representing the name of the file that we want to open, and also whether or not we want to read, write, or append to that file. So notice we're selecting R here. So that's to read to the file. If I used a W, that would be opening a file to write to it. And I can also specify an A to append to it. So they've selected the option to read in this example. So there's an example of a class method there to create a new channel object. We're passing the reference to that object back to a variable defined as a channel object called myChannel, and then we're using object methods to go ahead and read a particular file. Here's an example of the string buffer class from the base package. So let's see what we're doing here. Grab a highlighter. So it looks like we're going to use some object methods here. We're defining a variable called buff, and it's variable of type string buffer. So here we're using a class method at the top. Let buff equal base.stringbuffer.create. So we're creating a new string buffer object and assigning the reference to that object to our variable buff. And then we're using this object method, buff.append, to append ABC, DEF, 1, 2, 3, 4, 5, 6 to our new string buffer object. Once we're finished appending values to the string buffer object, we're using another object method, buff.toString, to create a string from that string buffer object. So that actually creates a string, and in addition to that, we're displaying the string. So a few things you can do with the string buffer class. Here are a lot of the methods with the string buffer class. I believe there's more than we see here. There's a lot of methods for the string buffer class, but this is a good listing of them. So there's the create method that we saw a minute ago. This is the only class method for the string buffer class. So that's the only class method. All the rest of these methods that we see down here are all object methods. So there's the append that we saw the example of on the previous slide. Lots of other methods you can use to do comparisons, equals, ignore case, finding a certain index in a string, or string buffer, excuse me, get the length of a string buffer object, all kinds of good methods there to manipulate string buffer objects. Here's the object to convert the case to lowercase. There's an object to convert it to uppercase. Excuse me, I've got allergies today, so I apologize ahead of time for coughing. I'll try to mute myself if I need to cough. There's a lot of stuff in the air here in Dallas today. Okay. So here's the string tokenizer class. I mentioned earlier that the string tokenizer class is used to parse strings to extract what they call tokens. You use a delimiter, you give it a delimiter, and it will actually look for what they call tokens between two delimiters that you define. And what it returns is called a token. So here's our example. Main, we're defining talk, which I assume is short for tokenizer, as a string tokenizer object. And then in our code, let talk equal a new string tokenizer object that we're creating with the create method. Right, so that was our class method for the string tokenizer objects. So we're creating a string tokenizer object that consists of /home/Tom. And here when we call that create method, we also are specifying the delimiter that we want it to use to be able to search out and find these tokens in the tokenizer string. So here is an object method in a while loop. While has more tokens, which just returns true when there's more tokens to return. So we have a while loop, and it's traversing this tokenizer object looking for tokens between these slash delimiters that we've passed it. So when it finds a token, it will display the token and then continue on in the while loop. So traversing a tokenizer object, finding tokens based on this delimiter that we pass to the method. Here's some more methods from the string tokenizer class. There's the create method we saw on the previous slide that we use to create a new string tokenizer object. Here's a create extended tokenizer, which is the same thing except that it's a little bit smarter and can handle nulls and escape characters, but it's still a create method. And then we have some object methods. Count tokens, that returns the number of tokens that can be returned when it goes through and parses the tokenizer string buffer, the string tokenizer, excuse me. And then the next token we saw an example of also on the previous page, just parses the string and returns the next token. So from the base package, we're going to look at the UI package, which I have a tendency to want to call the UI package, but it provides classes to work with the user interface, so it has a good name, right? UI for user interface. There's several classes in the UI package. There's the interface class that you can use. It's, they say, the root to the user interface. It's just methods that you use to manipulate the user interface. There's the window class that, of course, we use for window manipulation. We saw an example of that earlier in the chapter. There's a class for ComboBox handling, handle the ComboBox form item. There's a form class that, of course, we use to manipulate forms, and a dialog class. That's an interface to all the interactive instructions of a program. The construct, input array, menu, for example. So the first class we'll look at in the UI package is the interface class. It's just a built-in class to manipulate the user interface. It's all class methods. So all those things we saw earlier that we have to do to work with object methods aren't necessary with the interface class. We just use them straight out of the box, so to speak. So a few examples here on this slide. Display type equal UI.interface.getFrontEndName. GetFrontEndName is just a method that returns a string for the type of the front end that's being used. GDC, for example, or GWC. GDC, of course, would be for the Genero desktop client. GWC would be the web client. So that's what that method does, is return the type of front end in a string. The next example they have here is getFrontEndVersion, which would be the version of whatever front-end client you're using. For example, 2.50, and then yada, yada, yada. Usually there's a little bit more to it for the version, but just the version and the front-end type are what we see for these two examples. Both class methods. Those are simple. Here's some additional ones. We'll actually be looking at these in a later session. We've got some interface methods here to load your own XML files that you've set up with customized elements into the abstract user interface. If you remember our first session, we talked about the abstract user interface and how you can manipulate the abstract user interface because it's a DOM tree, right? So we can manipulate the nodes in the tree, add nodes, delete nodes, and so on, change the properties. So we can do a lot at runtime with the abstract user interface. So these are interface methods that we can use to load up our own XML files with customized elements into the abstract user interface. We'll actually talk about these in detail on July the 31st. So if you're interested in toolbars, start menus, top menus, action defaults, and so on, a lot of that will be in the July 31st session, where we'll talk about these methods and a lot more about toolbars and start menus and so on. So here we'll just kind of glance at or take a quick look at some of the methods we can use to load these customized files, the contents of these customized files into our abstract user interface. So an example here at the bottom, call UI.interface.loadToolbar standard. So notice we don't have to specify a path or a file extension with these customized files that we've created. It's automatically going to search a DB path environment variable for that file. And it's smart enough to know what the file extension needs to be. And again, we'll talk about this later, but for example, for a start menu, right, it knows that a start menu has to end with a .4sm. And a toolbar, the file extension has to be a .4tb. So it figures that part out. So when you use this method to load your XML file with your customized elements, you don't have to specify a path or an extension. And it will figure that out as long as the path is in a location in your dbpath environment variable. There's another interface class method called front call. We'll look at a few examples of the front call method. Front call actually lets you call functions defined in the front-end client. So it actually gets executed locally on the workstation where the front-end client resides. So you can write your own series of functions if you want to in a module of your own naming. That's what we see here. So when you call this front call method, grab a highlighter here, you're going to have to pass it the name of the module where you've set up your functions, where you've defined your functions. You have to tell it what function you want to execute. And then you can also, of course, pass it parameters for the function that you're calling if it requires parameters. The out list is a list of parameters that get returned from the front call function. So it's a unique method where you can call functions from an existing module that you create. Now another example of a front call method is this one. There's actually a predefined module that our engineers have already set up for you that has a lot of good functions in it that you may want to make use of. It's called standard. So when you use the front call method and you specify standard as the module name instead of a module that you yourself have created, that gives you access to all of the methods, functions actually, excuse me, the functions that are in that predefined standard module. Give me 1 second here. Let me shut the door. Sorry about that. We had some background noise today. Hopefully that's better. Okay, so back to this front call example. So there is a special module of functions already created for you called standard. And if you want to make use of any of those predefined standard functions, all you have to do is use standard for the module name and then specify, like we see here, the function that you want to use in that module. So CB always makes me think now of ComboBox, but this particular CB is not a ComboBox. This is a clipboard function. So they're using a clipboard function from the standard module, predefined module, and it's just a built-in clipboard function to copy "this is a test" to the clipboard. And also, you can see here, it has a return code that's just going to be true or false, the execution result, whether it was successful or not. So a predefined module of functions that you can utilize by using the front call method. Some other standard functions. So what they mean here, of course, is using the front call method using standard as the module name. So standard as the module name. Got a function here to execute an application. Get some front-end information from the front end, like front-end properties, type, OS version, that type of thing. There's a shell exec function that opens a file on the client machine with a associated program. It uses the file extension to figure out what program it should use to open the file. get environment variables. So this one closes a module or a library, MD close. So a lot of good built-in functions that you might find some uses for. There's also some what they call dialog functions that open a dialog window to prompt for information, like a directory path that you want to use, file path, save a file to a specific path. So these are all dialog functions that open a dialog window and prompt for information. And some clipboard functions like the example we saw before. So several of those. We saw CV set. There's also a CV clear to clear the clipboard, get an object from the clipboard with CV get, and so on. So standard functions. A rather unique method there, that front call method. So here's a front call example. I think this is the last one, and then we'll move on to something else. But this is calling your own client-side function. So they're not using the standard module here. They're using a module that they have created with their own functions. And just to walk through this real quick, here they're setting up a variable key equal to this particular registry key. I'm not going to read all that off. It would take too long. Item is another variable they're defining as current version. So those are all parameters they're going to pass to their user-defined function, programmer-defined function. Here they're using the front call method. The name of their module with their function in it is called GetReg. The name of the function in the module is also GetReg, a little redundant. Here's the parameters that they're passing into their function, which is this defined key and item variables that we see up here at the top. And then there's a value being returned, probably the status, right? The status, whether it was okay or not okay, true or false. So there's an example of somebody looking something up in the registry with a special GetReg function that they've created. All right, so some additional interface method, UI.interface class methods. I've got the set name to set the name to identify the program on the front end. Get name. We saw set text, I believe, earlier. So just a bunch of program methods to get information about the application or manipulate the application is what we see here with these interface class methods. Here's a few more. Get type, return the type of the program we talked about a page or so ago. Some methods here to work with containers. Refresh, synchronizing the front end with the current AUI tree, Abstract User Interface tree. So let's move on here to the window class. We saw an example of a method in a window class earlier. But here we'll get a little bit more exhaustive list of the methods. There's two class methods you can use with the window class to get a reference to a window. Right? The first one, forName, returns a window object named by an open window statement. So to use that method to get a reference to the current window, you actually have to use it by name or name it. The second method, getCurrent, is used more commonly. You see this more in applications because it's easier. GetCurrent just returns the current window, right? The current window object. So that's the one you see more commonly because it doesn't require you to have the name of the window. But you can see uses for both. So that's the more common method. And then down here are all the object methods for the window class. You can manipulate the window. Now that you have a reference to the current window, you can do all kinds of things to it. Get node to return a node for a current window, get text to get the title of the window, create form, create an empty form and return the new form object so you can manipulate the form now with form methods. We'll see an example of that, I believe, here in a page or so. So here's an example, another example of the window class. So here we're defining W as the window class type, opening a window, W1, and then we're using this window.getCurrent class method that we saw on the previous page to get a reference to the current window. And then we're assigning that to W. So like our example early on in the chapter, W now is a window object that has a reference to our current window. And then we're using object methods, right? A window object method called setText to change the title of the window to Illinois customers, IL customers. So that one we've seen something very similar. Here we've got the ComboBox class that gives us programming methods for populating and manipulating ComboBox objects. So here we've got a class method for name. So that for name searches for ComboBox objects by the form field name. That's the reason I call it for name. The form field name in the current form. And then once that combo object is found, then you can pass it on to an initializer function. We'll see an example on the next page. So we'll see an example of this set default initializer class method as well in that example. Then once you have a reference to a combo box with a class method, then you can use these object methods to add items to the combo box and manipulate the combo box. So here's an example, a ComboBox example. So here it says we're defining an initializer function for a combo box. So up here at the top, we're defining CB, a variable of a ComboBox class type, opening a window with a form, cust form, and then we're using this for name class method that we saw on the previous page excuse me, to retrieve our ComboBox object. And we're looking for the one with the form field name customer.state. So it's going to search for that combo object based on that name. Then when it retrieves the ComboBox object, we're assigning it to our variable CB that we've defined as a ComboBox class type. And then we're calling this initializer function and passing it to the initializer function CBInit. So down here we can see this function CBInit that we're passing our ComboBox reference to. And you can see it initializes our ComboBox and then adds some items to it. And you can also do that programmatically, right? These are hard-coded items that we're adding to the ComboBox. And by the way, you can also set up an initializer function in the form as well. Instead of doing it here, you can call it in the form attributes for a .per file, or the form properties if you work with Form Designer, the .4fd files. So there's a few ways to do this. In one of our later sessions, we'll talk more about combo boxes and we'll revisit all of this. So think of this as more of an introduction to one of the ways that you can load your combo box and initialize it. We'll come back to it later. Here's the UIForm class, UI.form. And of course, just from the name, you can tell it's our class that has methods that we can use to manipulate forms. There's a class method called setDefaultInitializer that we'll see in an example here in a page or so. And there's a lot of object methods that we can use to manipulate forms. These are fairly common methods. You see these a lot because there's methods in here to do things like load toolbars, load action defaults, things we'll talk about in later sessions. So again, think of this more as an introduction. But you can do things with these methods like hide and show elements or fields in a form. So that's something you can do programmatically at runtime by using these methods. Here's an example of using the setElementHidden method. Again, pretty common things for people to want to do in an application. So here we're defining W as a UI.window object, F as a form class type. Opening our window, we're using this window.getCurrent method, class method, to get a handle on our current window. The end result is we want to get a handle on the current form, but to do that we have to use the method first to get a reference to the current window. So here we're getting a reference to the current window and passing that reference to W, and then using a window object method we're going to get a reference to the form, w.getForm, and then pass the reference to the current form back to our variable F. So now we do have a reference to our current form, and we can use methods now for form methods to manipulate the form. So here we are in an input on action. So if a user selects an action or triggers an action hide, we're using this .setElementHidden, and then we're passing it the element that we want to hide there, customer.storeName. We're also passing it a 1 or a 0 in this example. So setElementHidden and passing it a 1 means true, right? So we're going to hide the store name with that first example. Then on action show, if the show action's triggered, we're going to use the very same method again, setElementHidden, same element. This time, no, we're passing it a 0, so it's going to be false. Right? So setElementHidden will be false, so that means we'll actually show the element again, the store name again. Here's the setDefaultInitializer method. The setDefaultInitializer method is handy because you can specify a default initialization function for all forms. Any forms that your application works with can have the same default initializer, and it's a good way of standardizing. So here, this particular function, the default initializer we're using here is init, and if we look at the init function, all of our forms are going to load a top menu called My Menu. So it's a nice way to standardize across all forms for an application. So that's a handy method for, we'll call it standardization. The dialog class is an interface to all the interactive instructions. We talked about a few of those a minute ago. Input, display array, menus, any of the interactive instructions that you can think of support dialog class methods. So one thing that's different about the dialog class is you don't have to actually do all the stuff we did before to get a reference to a current dialog. It's smart enough to figure that out, right? It'll figure out what interactive instructions you're currently in, and it will automatically give you a handle to the current dialog object. So that's a nice thing about this UI.dialog class in the methods. So it's automatic. You just use the predefined dialog reserved word, and you can automatically use the methods associated with that class. So here's some of the class methods. Get form to return the current form. Set action hidden. Set action active. Set field active. Set cell attributes to work with arrays. A lot of different methods that you can use inside of interactive instructions. So you don't have to explicitly define a variable of type UI.dialog to use these methods. Right? It's automatic. Don't have to use a class method to acquire a reference or create a new one. You only have to reference the name dialog in one of these interactive dialogues, and it'll figure out which one is current. So it tells you, too, that interactive dialogues are objects. It's kind of a strange concept that since they're objects, you can do a lot with methods inside interactive instructions now. Here's an example, a UI.dialog example. It's a hard habit to break for some reason. So here is, grab a highlighter, opening a window, W1 with a form. We're in a menu interactive instruction. It's smart enough to figure out that we're in this current interactive instruction menu. All we have to do is say call dialog. Right? So we're calling this dialog class using a set action active method, and it's a negative here. Right? So we're setting the action next to false before we're in the menu interactive instruction. On action find, we're calling a function, and if the function comes back with some rows, it looks like, call query cust, returning query OK. If everything works out okay, we're going to call dialog.setActionActive next. Same method. This time, though, we're passing it true. So now that we have some rows returned from our query, we want the user to be able to trigger the next action. So there's an example of setActionActive, disabling and enabling actions in the interactive dialogues. So it's smart enough to know what the current interactive dialog object is, right? Figures it out. Something else that you can do is use methods to enable something called multiple row selection. So we have multiple row selection support and some methods to handle that. Again, we're still talking about the UI.dialog class that these methods are available in. So automatic binding to standard key control, things the users are already familiar with. So these methods support control click, shift click, and so on to highlight these rows that they want to select. So by default, multiple row selection is disabled. Right? We don't have multiple row selection turned on by default. So one of the methods that you'd be interested in to utilize multiple row selection is set selection mode. So to be able to turn on multiple row selection, the first thing you'd need to do is use this method, set selection mode, and enable multiple row selection for a particular screen array in the example. Pass it a 1 to enable it. So by default it's turned off, and you have to use this method to turn it on. The isRowSelected method is used to figure out whether or not a row has been flagged as selected. So that's the method you use to see if a particular row has been selected. And let's say you have an action available to users to select all rows, for example. You can use this set selection range method to programmatically go in and select a whole range of rows by passing it indexes, for example, starting, ending index, and so on. So that allows you to set the selection flag for a whole series of rows, kind of a shortcut. One thing, multi-row selection is only supported in GUI mode. So if you use TUI mode, this would be something you'd want to be cautious of because it's only supported in GUI mode. We'll actually readdress multiple row selection in one of the other sessions. I'm trying to remember what the date was for that one. I believe it's the July 17th session. So if you're interested in implementing multiple row select, we'll go through it in a lot more detail in that session on the 17th. Here's a few pages on the OM package, what they call the Object Model Package. Historically, the classes in the OM package were used to code methods to manipulate the DOM. You can see from just looking at all the classes that that's what this package is for, manipulating the DOM. So typically used to do things like show or hide fields or actions, making them active or inactive. But we've seen some examples just the last few pages where now we have some special built-in classes and methods that are actually made just for that, right, to hide and show fields or actions. So it's not used as much as it was historically. It's still used, though, because there may not be methods to do everything a user might want to do. So we have the OM package that you can use to get down, I guess, to a little bit lower level and manipulate the DOM. There's methods here to read and write, XML, manipulate nodes in the DOM tree, and so on. Here's an example of methods. So here we're, grab my marker, defining a couple of variables. This one's a DOM document object type, and this one's a DOM node class type. We're using a class method here, DOM document.create, to create a new empty DOM document called myDocument. Actually, myDocument is the name of the root node in the DOM document. And in R, using a method called getDocumentElement to return the root node of the DOM doc and assign that then to our variable R. So there's a few methods there. The first one is a class method to go out and create a new empty DOM document. And the second method is going out and actually returning that root node and assigning it to R. And now you can manipulate, add nodes, for example, to the new document. Okay, so that is the three, make sure my count's right, the three packages that you can use out of the box without having to do anything special in your code to, say, load the package, for example. Now the OS and the util packages that we're looking at last here in the first part of this session are actually just a little bit different. They're actually provided as dynamic C extension libraries. And they're part of the standard install package, but they're not built into the runtime system. So to use the methods that we see here, you can see a lot of these methods are to manipulate files and directories kind of outside the program environment. These actually have to be imported. So the os.path class and the util package classes that we'll see in a few pages have to be imported to use them. But that's it. Very simple to do. It's not a difficult thing to do, just slightly different. One thing, when we look at the documentation, you'll notice that the OS package and the util package also isn't with the other documentation for classes, where we see like the base package, for example. They're actually in a separate area of the documentation that I'll show you, where they keep information about utilities and libraries and that type of thing. So they are actually kept separately. So here we see the methods for the path class. You can see most of it is to manipulate files and directories. separator, just to go through a few of these. I won't go through all of them. It takes a long time. That would return the character used to separate path segments in a path to a file. The path type for a file determines the path if it's relative or absolute. To see if a file exists, we have an exists method. See if a file is readable or writable, we have those methods: readable, writable, executable. What else? File type, file size, last access time. For Unix clients, we've got methods to change the owner of a file. These should look pretty familiar. Return information, user ID, group, permissions on files. We can return that information. Change permissions on a file with that method, CHRWX, and so on. You can see there's a lot of different methods here to manipulate things outside the programming environment, kind of OS level methods, directories, files, and so on. Here's the math class, which I find a little frightening. Nervous of math, always have been. So here's the util.math class, and the util package I mentioned before is like the OS package. To be able to use these methods, you actually have to import the util package to be able to use it. So, not a big deal, but it does have to be done. Okay, and along with that, here are last 2 or 3 pages are on some of the utility functions and extensions that you should know about. There might be some methods here that you might really be interested in, or functions, I should say, that you're interested in here in the utility functions. So here they're talking about utility functions are provided in a separate 4GL library. They're not built into the runtime system, so you have to link with the utility library to use them. It does have a name you might be familiar with. libfgl4js is the name of the utility library. Here's the path, where you can find the .42x, the library file, 42m modules, and .42f files. And the actual source and form files for those utility functions are under fgl-dir source. So a lot of good functions there that you have available if you want to utilize that built-in utility library. Dialog functions, there's some database functions that you might find interesting. The front-end functions and Windows client functions, for the most part, they're recommending you use another method that we've talked about. We'll see that here in a second. So some of the common dialog functions you may be interested in using: FGL Win Message displays an interactive message box with multiple choices in a separate window. Win Prompt displays a dialog box with a field to accept a value. So you could certainly code these yourself, but these are built-in functions that would be a little bit of a shortcut for you if you want to use them. A couple of database functions. DB Get Database Type returns the type of the current database. DB Start Transaction starts a new transaction if none is started. I have a typo here. Let me just point. Oops, that should not be there, right? So that Get Database Type returns the type of the current database. And then down here, the DB Start Transaction starts a new transaction if none is started. And here they're saying UI.interface.frontCall, we looked at a few minutes ago, is recommended to use in place of front-end and Windows client-specific utility functions. So we actually replaced those with front call methods. different place to find those methods we prefer you to use. The Java interface was introduced in VDL 2.20, and it allows you to import Java classes. If you want to use Java classes, you can use those now with your VDL programs. You do have to do the expected things. You have to install the Java Development Kit on the development system, runtime environment on the production system, and you have to import the class. So this is similar to the OS and util packages that we talked about a few pages ago. So it has to be imported before you can use the classes. Again, the doc is in a special place. I'll show you when we finish the actual presentation part. We'll pop over the documentation and take a look. And the last thing here is C extensions that you can use to integrate your own C libraries in the runtime system. So there's using shared libraries to implement. You don't have to relink. You do have to have them configured as shared objects, so a DLL on Windows or a .so on Unix. And then you have to bind or load your C extensions at runtime, and there's a variety of ways you can do that. Kind of the preferred method is to use the import instruction, like we saw with some of the utility functions a minute ago, and also the OS and util packages. We use the import instruction to load those. So that's the preferred method, but it requires editing possibly a lot of source code to do that, a lot of files. So they have alternate methods. This one here, using the default C extension name, user extension. If you just use that name, create your shared library with that name, then it'll automatically load it at runtime. So you don't have to go in and change your source to load your C extensions. That's a little bit of a shortcut. And then finally, the last method, specify the extensions to be loaded with a -E option of FGL run. You would use that method, for example, if you perhaps have multiple C extensions that you want to use, multiple files. So you could use that method when you wouldn't be able to use the user extension. That's just one file. So that's for folks with multiple C extension files. So it will automatically, just kind of reiterate, this default C extension name, user extension, it'll automatically load that as long as you have it specified, or as long as you store it in a path specified in FGL-LD path. So as long as you have FGL-LD path set to a directory where you have that user extension file saved, it'll automatically find it and load it. Okay. So that's our, I won't say quick summary. It took us about an hour and 15 minutes or so to go through the classes at kind of a high level and look at some of the methods for those classes. I'm going to show you the documentation and how it's laid out and where to find some of these special utility function documents. The OS and util packages are in a little different location. I'll show you all of that as well. But before I get to the documentation, does anybody have a question? Anybody have a question before we continue on? Give you a second. Okay. All right. Well, I don't see any questions. So let's take a look at the documentation. Pop this out of the way. So here we are in the BDL documentation. The class documentation, here's built-in classes 1 and built-in classes 2. So there's two different sections here with documentation on the built-in classes. Let's just pick one here that looks familiar and take a look at it. Take a look at this UI.window class. Notice that every class has a syntax link. If you click on the syntax link, it'll take you right down to show you the syntax. So of course the syntax we've described already, UI, the package name, dot class name, and then it will show you all the methods. And notice it differentiates between class methods and object methods down here at the bottom. So the window class has two class methods. Oops, I didn't mean to do that. Let me go back. Two class methods. We have the forName class method that we talked about, where you can go and find a reference to a particular window object by name. And we also see the getCurrent class method that we can use to get a reference to the current window. So that's the one we talked about. People use more commonly is getCurrent just because it's a little simpler. There's several object methods, and you see all the object methods below the class methods. And we saw already by my mistake that you can click on a method. It has links where you can go and see more details about the method, how to use it. There's some code snippets usually at the bottom. So down here at the bottom we see some examples and some code. So that makes it easy to learn about the classes and how to use the methods, because the documentation, I think, is very good. It's very thorough. So you see the syntax, you see the usage, and then almost always at least a few examples at the bottom that you can use for helpers. All right, so let's pop back in here for a minute. So we see these built-in classes 1 and built-in classes 2. One thing to notice is that I see the base package, the UI package, and the OM package here in our built-in classes documentation listing. But notice we don't see the OS package or the util package here. Right, so the classes and methods for those are not with the other classes. So you have to find them down here in the library documentation section, down at the bottom, below the classes. So let's see if I can remember. File manipulation functions, if I click on that, notice here we're talking about the OS package, right? So there's the OS package and the classes to go with it. So different location, you have to look for it a little bit differently. So there's the OS package. Let's see, mathematical functions. If we click on that, there's our util package. Right? So that's how you find the documentation for the OS and util packages, is look below the actual class documentation up here, look in the library documentation. Also, the utility functions that we just covered at the end of the session are under the utility functions in that library section. So here's the utility functions. Here's a list of them. There's the common dialog functions we talked about that pops up a separate window, prompts for information, the database utility functions, and here are the Windows client-specific functions and front-end functions that we said they suggest that we use UI.interface front call methods instead. So we can see that a reminder here. All right. So most of our class documentation is under built-in classes 1 and 2, but we also have some class documentation under the library section, file manipulation functions and mathematical functions. And over here, since I see it, might as well point it out, here's your Java interface documentation, step-by-steps on how to use the Java interface with your BDL code. And then right below that is step-by-step instructions on the C extensions and how to configure those. Okay. That wasn't too bad. 12:22 or so, and we've finished our session for today. I want to thank everybody for attending the session the day before a holiday in the U.S. I know a lot of you are from the U.S., so you might actually be missing out on getting a half day off today, so I appreciate everybody showing up. The session, again, will be recorded, so if you weren't able to attend the first part of the session or you missed part of the session, check for the Watch Recording link. You can find that where the Register Now link used to be for the session out on our instructor-led training page. You'll get a follow-up email later today, and I'll have the link for the recording there as well. Well, thank you very much, everybody, for attending. I hope very much to see you on our July 17th session. It'll be What's New in Interactive Dialogues. So we'll talk more about the interactive dialogues and the dialogue methods that we discussed briefly today. So again, thank you very much. If you have any comments or questions or anything you want to ask me, feel free to use the email that we saw earlier in the session, lchildress@4js.com. Thanks a lot, and hope I see you in 2 weeks.